Hey, it is time for geometry. So, ready for the day. It's sun's coming out today. It looks like maybe it'll start warming up after that big freeze we've had this week. It's gotten cold. I'm ready for some spring. I don't know. April. Where you at, spring? Come on, get with it. Let's get to our lesson today. I'm going to switch our camera over. Okay, make sure we're good to go there. Okay, let me make sure that is perfectly focused as best as I can. All right, weighted averages. All right, we're looking at weighted averages today, and we're going to do that using some line segments. Okay, so you say averages, lines, I don't know. Let's see. Now for the questions here, we have a coordinate grid we can use if it's helpful to us, if we need it. We'll see what we do with that. Number one, our question is, what is the midpoint of the segment connecting 1, 2, and 5, 2? Now we can graph those points, 1, 2, and 5, 2, and we could see where their midpoint is, but I want to show you how to do it when it's not so simple. See, we can look at that and say, what's halfway through? Well, that's right there, obviously, right? Right in the middle, 3, 2. But an even easier way to do it, if graphing's not so obvious, is we'll take the two x's. The x's are 1 and 5, right? 1 plus 5 divided by 2. That'll find the average. Average. We're talking about weighted averages. The average between the two x's. So 5 plus 1 is 6 divided by 2. So that is a 3. And then the y is 2 plus 2 divided by 2. Right? Like in this one, it's really simple. So 2 plus 2 is 4 divided by 2. It's 2. So it's the 0.32, which we already saw that between that line segment. That would be, in this line segment right here, that would be the midpoint, right? So it's just as long on this side as it is on that side. But just add the x's together, divide by 2. That's how you take an average between two things. We're taking the average of the x and the average of the y. So what is the midpoint of the segment connecting 5, 2 and 5, 10? Now this one, the x is 5, 2, and the y is 5, 10. So this is a line that is a vertical line, right? It's a longer line. Got my ruler out today. So that segment there, what's halfway? Well, the x's is 5 and 5, so it's going to be a 5. 5 plus 5 divided by 2 is a 5. But what is the y's? It'd be 2 plus 10, because that's the two y's, divided by 2. What's 2 plus 10? 12. Divided by 2, it's the 0.56, which, we'll see, the 6 is right there. We look at that, and visually, that certainly looks to be the midpoint, right? But those were easy because they were straight up and down or left and right, so we could just count and just go halfway. But when you get to 1, 2, and 5, 10, now what's the midpoint between here and here? All right, we can draw that triangle. That's going to complete our triangle, basically, right? Going from 1, 2 to 5, 10. What's the midpoint of that? Well, it looks like it's going to fall right there in this point. Doesn't always fall in a point. 1 plus 5 is 6 divided by 2. So the x is at 3. 2 plus 10 is 12 divided by 2. Should be at the 0.36. 1, 2, 3, 6. It is right at that point. So that is the midpoint of the sides of the triangles. And all we do is we add the x's together, add the two x's, divided by 2 to find the average. What's the average between those two numbers? It's a 3. What's the average between the y's? Well, since they're the same number, it's a 2. So, weighted averages. Okay, we can do that. That's not so bad. Let's look at this. Part-way segment. Okay, so point A has the coordinates 2, 4. There it is right there. And point B has the coordinates of 8, 1. All right, and this says, it doesn't say find the midpoint. The midpoint is going to be, not on a actual point of the grid where an x and y meet. This says find the point that partitions. Partitions just means to divide it, right? When you partition something up, you put a divider between two things to partition them, or between 5 things and partition them all out. This is that partitions the segment AB in a 2-to-1 ratio. All right, let's talk about that. I thought about just changing this to midpoint and keeping with the midpoint, but it's important to understand ratios because you'll see that on any kind of ACT, Aspire, a lot of the standardized testing, and you see it sometimes out in the workplace and different things where things are at 2-to-1 ratio. So what does that mean to be at a 2-to-1 ratio? Let me give you an example. All right, I have some M&Ms. All right, I usually have some M&Ms. I have some M&Ms. And if I were going to take all these M&Ms I have, how many do I have? 2, 4, 6, 8, 10, 12. And I'm going to share them with you. And I'm going to share them with you in a 2-to-1 ratio. That's how this would work. I would take 2. That's 2 for me. And then you would get 1. 2-to-1 ratio. I get 2. You get 1. I get 2. You get 1. I get 2, you get 1. I have divided the M&Ms in a 2-to-1 ratio. That means I have 8, you have 4, right? If I write my 8 and your 4, that is 2-to-1. For every one of yours, I have 2. That's a 2-to-1 ratio. And no need to let these go to waste. We're going to eat our... Oh, now we're 1-to-1s. That's good. But... more M&Ms. So, I may have to do a couple of takes of this recording. Do it a couple more times more, just to make sure. You're not going to eat yours? All right, I'll go ahead and I don't want them to go to waste. Yeah. All right. Let's have a Coca-Cola. All right, what we're doing. If I can find anything with the Reese's. Oh, that's right. We're partitioning segment AB in a 2-to-1 ratio. So that means we need A. A is the first one. It gets to be twice as long as B. So for however long B is, A is twice as long because it gets twice the portion. It gets twice as many M&Ms. So how would we do that? Find the point that partitions that in a 2-to-1 ratio. So let's find out how long it is. Okay, we'll find how long it is. So from this point to this point, we can, well, I got that ruler there. Let's use it. We can make a right triangle. And with our right triangle, this side has a height of 3. 1, 2, 3, 4, 5, 6. So we'll figure out how long that is. 3 to 6. So use the Pythagorean theorem. 3 squared plus 6 squared will equal the side we don't know. This is 9. 3 times 3 plus 6 times 6 is 36. Equals c squared. So 45 equals c squared. So this is going to be the square root of 45. So the length of that, c is the square root of 45, is not a nice, fabulous little number. This would break down to be 3 square roots of 5. So that didn't work too well. What other method can we try? Now, wait a minute. When we were finding the lengths of the sides of that triangle, it was 6 long. We can divide that up at a 2-to-1 ratio, right? So from left to right, if it's 6 length, A would get how much of that to be twice as much as B, because they get 2-to-1 ratio, twice as much. So they should get 4, and B would get 2, right? So A is going to come all the way to here, right? A is going to get that much of the left to right part of the line. Up and down is 3, and we're doing 2-to-1 ratio. So of those 3, A gets 2 of them, B gets 1. So A would get 2 of them and come right here. So this is a 2-to-1 ratio. So this point right here, the point 26, I'm sorry, 6, 2, do the X first. That would be the point to where this portion, let me get my highlighter. This portion here is A. That's when we divided it, that's how much went to A. And then just this part right here went to B. So this would be twice as long as that. And if we found out the length of it all, if there's 3 square roots of 5, this would be the square root of 5, and this would be 2 square roots of 5. Right, so we could check that by this is a 1 and that's a 2. So 1 squared plus 2 squared is 5. So that length is the square root of 5. So there was 3 of them. That's square root of 5, and there's 2 more over there. 6-2. 6-2. Let's see what they want us to do here. This looks a little different. Calculate C, this point C. 1/3 times A and 2/3 times B. Okay. A is 2/4. So 1/3 of 2/4 plus 2/3 of 8/1. Okay, how do we do that times a point? We're just going to multiply it by the x and the y in there. So 1/3 of 2 would be 2/3. Right, 2/3. And 1/3 times 4 would be 4/3. Remember, when you multiply a fraction, 2 times 1/3, 2 is the same as 2 over 1, and you multiply straight across. 2 times 1 is 2, 1 times 3 is 3, so it's 2/3. And we did the same thing with the 4. It'd be 4 over 1, so 4 times 1 is 4/3. All right, 4 times 1 is 4, and 1 times 3. So this is the first point, A, multiplied by a third. Now B is 2/3, so 8 times 2/3 will be 8 times 2 is 16, and 1 times 3. So this is 16/3. And the other would be 1 times 2/3. So this would be just 2/3. And we're supposed to add those together. Well, to add those, you have to add the x's together. We can't add an x and a y. X's would go together, y's would go together. So 2/3 plus 16/3. How many thirds would that give us? Well, when we add, we keep the denominator. That's going to stay a 3. And we add 2 plus 16. So that is 18/3. 4/3 plus 2/3. If I have 4/3 and I add 2 more thirds, now I have 6/3. Well, we can simplify those fractions, right? Because that's 18 divided by 3. 18 divided by 3 is 6. So that's the same as 6. And 6 divided by 3 is 2. What do you notice about your answers to the first 2 questions? We have this one, and we have this one. This one, we were looking at it and trying to figure out 2 of them for A and 1 of them for B. This one, we just took 1/3 of A and 2/3 B. And we got the same point. Interesting. So, looking at this with 2-to-1 ratio, when we did the fractions, we had to reverse the 2. This went with the B right here. All right. The 2 went with the B. And the 1 went with the A, because we're moving it like 2/3 of the way towards B, and only 1/3 of the way towards A. So of that, it's kind of a little bit reverse. So let's look at the new points K and L. All right, we don't have an actual 8/4, 2/4, 8/1, no points, just K and L. So if we want to partition in a 3-to-1 ratio, a 3-to-1 ratio. Where's my M&Ms? No, that's okay. We'll do that. So an expression for the point, the partition. So we'll call it point D would be 3-to-1. This was 2-to-1. So it'd be 1/3 K plus, this is 3-to-1. Oh, wait a minute. See what we're doing? Are we dealing with thirds? When we are partitioning something 2/3 to 1/3, I'm cutting it into 3 pieces, and I'm giving 2 of them to one, and I give 1 to the other. That way you get 2/3 of it, they get 1/3. What are we doing here? 3-to-1. 3 to 1. So how many pieces do I got? I add those together. I've got 4 pieces, and I'm going to give 3 to this one. I'm going to give 1 to that one. So we've got to pay attention to how many pieces we're cutting it up into. And I wasn't paying attention. So this only gets 1/4 of the pieces. And this is 3/4 L, right? Total pieces would depend on how you need to divide that up. 3 to 1. If I cut it in 3 pieces, I can't give 3 to 1 and 1 to the other because I don't have that many pieces. Add those together to figure out how many pieces you need. So 1/4 times 3/4. All right, let's look at something else here. Partway, triangle. Triangle ABC is graphed. Yes, we do see that. It is right there. Find point D that partitions segment AB. So we're looking at AB. We're looking at this one right here. In a 1-to-2 ratio. All right. Now this is how you wanted me to hand the M&Ms out. 1-to-2. I'll take 1 and you get 2. See, whichever one goes first. So this time A gets 1, B gets 2. Pay attention to the order. 2 to 1 is different than 1 to 2. And we want to find that, so the A gets 1 and B gets 2 between these points. Okay. Let's try doing it with our formula. I mean, this is straight, and we know we can do that, but let's see if our formula works. We had said if we took D, and since this is a 1-to-2, it's 3 pieces, and we want A to get 1/3, so it's we remember reverse it, 2/3, and what is A? A is the point 1-3. Plus B would be 1/3 on our formula. Remember, we reverse it, and this is 10/3. Just want to see if our formula works, because I know we can look at the line and figure it out because it's straight. It's easy to do. It's horizontal right there on y equals 3. So 2/3 times 1 would be 2/3. 2/3 times 3. Well, that'd be 2 times 3 is 6 divided by 3. So that is a 2. Or you can write 6/3. It might be useful to do that when we're adding it to the other one. But for now, I'm going to leave it as a 2. But it's same as 6/3. 1/3 times 10. Well, 10 times 1, that'd be 10/3. If you have 1/3 and you have 10 of those, you have 10 1/3. You have 10 thirds. 10/3. And then you have 1/3 times 3. If I have a third and a third and a third, I have 3 of those, right? I have a third and a third and a third. That means I've got 1. I've got 3/3. 3/3, which is the same as 1. So when I'm adding these together, 2/3 plus 10/3. 2 plus 10 is 12. So 12 divided by 3 equals the point 4. 2 plus 1, 3. Does that work? 1, 2, 3, 4. 1, 2, 3. That would be this point right there. So does that divide it up in a 1-to-2 ratio for AB? Well, A he gets 1, 2, 3. That's how long that is from A to point, we're going to call it point D. And then how far is it from D to B? 1, 2, 3, 4, 5, 6. So of the 9 units there were between A and B, and we divided it up between a 1-to-2 ratio, A got 3 and B got 6. That's 1-to-2, right? 1-to-2. Okay, that works. Find point E that partitions AC. Now this time, look at this, we're going diagonally up here, and we're not touching any point. We missed the points all the way. So this is going to be somewhere with a fraction, right? So we definitely want to use our equation this time, because trying to figure that out without having any points that we can measure is going to be a lot harder. So point E partitions AC in 1-to-2 ratio. So same thing, just using C instead of B. So it's the same formula. E equals 2/3, and that was times A, 1/3, plus 1/3. Again, thirds, right? 1 and 2, so there's 3 pieces. C is 6, 9. 6, 9. Okay, so 2/3 times 1 is 2/3. 2/3 times 3, again, is 2, because it's 6/3. Plus 1/3 times 6. 6 times 1 is 6. I have 6/3. That means I have 2, because 6 divided by 3 is 2. 9 times 1/3, 9/3. 9 divided by 3 is 3. So let's add these together. So this is 2 2/3. So I can write that like that because it might be easier to graph it. You can also put it together and say it's 8/3. 8/3. 2 2/3. 2 2/3. And then 2 plus 3 is 5. So if we graph the point, 2 2/3. 2 2/3. So about there, up at 5, right there. That is E. And it looks like that's probably a 1-to-2 ratio. That should work perfectly. All right, so this is A's part right here, and then everything from there is C's part. That should be twice as long as what A received. Great. So it asks us now, how does triangle ADE? Oh, let's make our triangle. If we take these points and connect them, okay, so we have basically created another triangle, the same A. Let's highlight this new triangle. How does this triangle relate to triangle ABC? Oh, dilations, right? It's a dilation, but how big is it compared to the original? Well, this is a length of 6. This is a length of 3. This is something, let's say fraction. It's not a nice length, but we don't need to know every side. If we know what the ratio between the two sides are, we can figure that out. So a lot of times look and say, well, this is 3 and that's 6, so it's half as long. Oh, no, don't make that mistake. We did that on a few quizzes and tests where we wasn't thinking. This triangle is 3. How long is this triangle? It's 9, right? This is 3, this is 9. So it is 1/3 of ABC. That's how big it is. It's just 1/3 the size. It's a scaled down by 1/3, dilation of 1/3. 1/3 of the original triangle. All right, that is all of our lesson, but I do want to go over, if you want any help with the problems, I'm going to show you the problems and what you need to do. We don't have a whole lot of problems today. I'm trying to keep that down. I've got 2 pages here. So this is what it's going to look like. The first one is going to say, consider this parallelogram. And it gives you A, B, C, and D. I've even added a graph. The book didn't have a graph. I added a graph of it just to show you that. Where do the diagonals of this parallelogram intersect? Now, we just had an assignment where we talked about the diagonals of a parallelogram and what the slopes would be. And some of you were giving me slopes of the sides. That's not the diagonals, right? The diagonals would be where it goes from one corner to the opposite corner. That is a diagonal. That is a diagonal. It has 2 diagonals, of course, also A to C. And it wants to know, where do they intersect? What point in there, when it comes across, what's that point? And, I'll have all the numbers on the graph. Got to be one of these. So what do you need to do? You need to find the midpoint, right? And the midpoint here, and if those are the same point, which, remember, in a parallelogram, the diagonals bisect each other, it should cut each other right in the middle. So that should be the midpoint between B and D, and the midpoint between A and C. So use our little formula to find the midpoint between there, and it should be one of those choices, multiple choice. All right, use that. What is the midpoint of the line segment that has these 2 endpoints? Okay, straight up, right there. Find the midpoint. Here's the problems on here. Gives you the vertices, and this one's, now this is obviously a quadrilateral. It's got 4 points, right? So when we connect them, it's a quadrilateral of some shape. But you need to select the most precise classification. All right? Is it just a quadrilateral, or is it also a parallelogram? Right? How would you check that? Well, if the quadrilateral is also a parallelogram, that means A to B and C to D would be parallel and the same length, and then A to D and B to C would be the other sides, and they would have to be parallel. So if you find these are parallel and these are parallel, then it's a parallelogram. If you find these are the same length and these are the same length, that would make the parallelogram. But is it also a rectangle? Because a rectangle is also a parallelogram, which is also a quadrilateral. So is it more precisely say it's a rectangle? If it's a rectangle, then when you find the slopes, they're going to be perpendicular, right? 90-degree angles. So if the slopes of two of those are 90 degrees, the other two have to be. So you say, oh, well, then it's a rectangle if those are perpendicular slopes. But even further, if all the side lengths are exactly the same length, it's quadrilateral, it's a parallelogram, it's a rectangle, and it's a square. So first you're checking to see if they're parallel, then you're checking to see are they 90-degree angles, then you're checking to see are they all the same length, because that will move you down to where you're choosing a different answer. And saying it's quadrilateral won't get you the points if it's a rectangle. And a rectangle won't get you the points if it turns out it's actually a square. You have to be the most precise classification. All right, and then the last one, write an equation whose graph is a line perpendicular to the graph of x equals -7. Passes through this point, -7, 1. I would have you think, what does the graph of x equals -7 look like? Let's see. I had a graph earlier, but it doesn't go to the negatives. So let me just say, what does the graph of positive x equals 7 look like? Where does x equal 7? Oh, it's right there. It also equals 7 right there, or there, or there, there. It's 7 anywhere there, right? So x equals 7 would be a line that is vertical, goes up right there. So if I want a line perpendicular, what would that equation look like? And it needs to pass through this point, where the x is -7, y is 1. That's it. If that's not enough help for you, get online. Come see me. I'm online every weekday, just waiting for somebody to hop online and say howdy, because I'm on there and got my headphones. And some days I don't have any students come on. Other days I have a few, and I'm always happy to hear you guys, to hear from you. Some of you keep your camera off. That's okay. Maybe you haven't got dressed today. I don't blame you. You're not going anywhere, right? Hanging around the house. Jammy day. Every day is jammy day. Wonderful. But anyway, I will see you next time. Do work you can be proud of.